Hi, we're doing Math 182, 10-3, number 8 for the online work, which is 43 in the book. It says determine the open t intervals on which the curve is concave downward or concave upward, where x equals sine of t, y equals cosine of t, and t is between 0 and pi. So remember, for our concavity back in Math 181, concavity was determined by the second derivative. So we look at our dy dt, dy dx is going to be dy dt over dx dt. And that's going to be the derivative of y is going to be negative sine t over the derivative of x, which is going to be cosine t, which gives us negative tangent t. Now, we need the second derivative. So the second derivative of y with respect to x is going to be the derivative with respect to x of the derivative with respect to x. That's going to be the derivative with respect to t of dy dx, what we just found, divided by dx dt. So our dx dt from the previous problem. So the derivative with respect to t of dy dx is the derivative of tangent, and that's going to be negative, because it's negative already, negative secant squared t, and dx dt is going to be what we found before, to be cosine. So we have the second derivative of y with respect to x. It's going to end up being negative 1 over cosine cubed t, because secant squared t is 1 over cosine squared t. So this is going to be concave up whenever pi over 2 is less than t less than pi. Why? Because cosine's negative there. So cosine cubed will be negative, and the negative of the negative is positive. It's going to be concave down then. Well, where's cosine positive on this interval? From 0 to pi. And at pi over 2, pi over 2. At pi over 2, it's not defined. So concave up, pi over 2 to pi, concave down from 0 to pi over 2. Okay, hope that helps.